Okay, so this lesson is, to be honest, kind of a hodgepodge. It's where we're taking all the concepts we've learned the past 4 lessons and combining them and stepping them up a notch. Okay, so this is a kind of a hodgepodge, but taking everything to the next level. Okay, so looking at this first one, it says multiply the 2 monomials together. So you talked about that a little in the properties of exponents, but again, it's a little more in depth, a little more in detail. Okay, so we start by multiplying our numbers together. 8 times 5, I'm assuming we all know, is 40. Now we're looking at our exponents with the same bases, so a. Remember, if there's no number there, it's an implied 1 on your exponent. So there, we have to add up our exponents, right? Same thing with the b's. Okay, so b2 plus 3. And now we simplify that, right? So we have 40. 1 plus 4 is a to the 5th. 2 plus 3 is b to the 5th. So that's going to be our answer there. Okay. Let's look at the next one because it's a little trickier. Okay. So we're dividing our monomials. So let's again just start with our numbers. So 30 divided by 5 is going to be 6, but I'm just going to put a little fraction bar here because remember it's 6 over 1. Looking at our y's, we have y2 over y5. Remember, when we divide exponents, we subtract them. So we really have y to the negative 3. What happens when we have y to the negative 3? Remember, when we have a negative exponent, it gets bumped downtown. It gets bumped down because we want it to become a positive. So now I'm going to put a 1 there, a y over 3 there. Again, we're multiplying each of these. And then our last one is our z. Again, we're dividing these values. So z to the 6th over z squared. And this one is z to the 4th over 1. So then now we just multiply these, okay? So I put those 1s in as placeholders just to kind of see the separation. If you don't need to see these 1s here, that's perfectly fine. You could leave them out. So then you would see that it's 6 z to the 4th all over y cubed. So again, we take it step by step, look at each thing individually, use our properties of exponents, just like the y. Sometimes you might have 2 properties to use at once. That's okay. Use as many as you need to. All right. Let's look at the next one. Again, things we already talked about, but we're taking them to the next level. Okay. So this is this whole monomial to the 3rd power. Just like an example before, we have to distribute that 3 to each one of these. So it's really 2 to the 3rd, and a squared to the 3rd, and b to the 5th to the 3rd. Okay, so it's everything to the 3rd power. Now we evaluate those. 2 to the 3rd becomes 8. When we take a power to a power, remember we multiply. So 2 times 3 is 6. Same thing, a power to a power, we multiply. So now 5 times 3 is 15. And then that's our answer. Okay, so you have to distribute that 3 in before we can evaluate them. All right, let's look at the next one. So we've kind of talked about this. This is a square root. So looking at each part individually, the square root of 16, hopefully you know, is 4. So the square root of 16 is 4. But now we have x to the 6th. Remember, we need to figure out how many pairs that has. How many pairs of x do we have? So 1, 2, 3, 4. So I'm going to write all my x's out and find the pairs. 1 pair, 2 pair, 3 pairs. So I have 3 pairs of x. If we had any left over, it would go back inside my square root. I don't have any left over though. Let's look at our y's. So we have 10 y's. So I'm going to write out all 10. 1, 2, 3, 4, 2, 8, 9, 10. And figure out how many pairs I have. So I have 1, I have 2, 3, 4, 5. I have 5 pairs of y's. So that's going to be my answer there. So again, we're looking for pairs because it's a square root. So we're looking for pairs because it's a square root. But looking at this next example, there's a crazy 4 right here. That 4 means that it's a 4th root. So this 4 means that it's a 4th root. So instead of looking for pairs or sets of 2, now we're looking for sets of 4. If it's a 3rd root or a cubic root, we'd be looking for sets of 3. So whatever that root is, we're looking for sets of that number. So let's start with our x's. So I'm going to write out all my x's. I have 8 of them. So how many sets of 4 do I have? So I have 2 sets of 4. So that means I have x squared. Remember, if I had any extras, like if it was out of 10 and I had 2 left over, those 2 would be going inside this 4th root side. We'd be going back inside the radical. Okay. Next I have is y to the 20. I'm going to write out 20y. It's going to take me forever. So 2, 3, 4. If it helps to write them into groups of 4, do it that way. Okay, so now I see I have 1, 2, 3, 5 groups of 4. So I have y to the 5th. The last one I have is my z. How many groups of 4 do I have? I just have 1. So it's going to be z to the 4th. And that's going to be my answer. Okay? So I want you to try your homework problems. And again, this is just kind of a hodgepodge, taking everything to the next level. So if you have questions, please ask.